All right, day 21. I think 1, 2, 3, 4, 5-ish days left. 21 through 25. Step counter. You managed to catch the airship right as it's dropping someone else off on their all expenses paid trip to Desert Island. It even helpfully drops you off near the gardener and his massive farm. While you wait, one of the elves works with the gardener, heard how good you are at solving problems and would like your help. He needs to get in his steps for the day, so he'd like to know which garden plots he can reach with exactly his remaining 64 steps. Gives you an up-to-date map, starting position, garden plots, and rocks. The elf starts at the starting position, which also counts as a garden plot. Then he can take one step north, south, east, or west, but only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. Second step could be at any other tile. This is interesting. Why are they showing it like that? Yada, yada, yada. Third step, continue until the steps are exhausted. After a total of 6, he could reach any of the garden plots. In this example, if the elf's goal was to get exactly 6 more today, he could use them to reach any of 16 garden plots. Okay, I think the first thing we do is we look at the algorithms that are available in the pathfinding crate. We've got undirected graphs and connected graphs. I think undirected, well, that was not the link that I thought it was going to be. These are all Wikipedia page links. I want them to be links to the documentation for that specific modules, cycle detection, directed graphs, rectangular grid. Oh, there's actually a grid type in pathfinding. That's cool. I wonder if we try to use that today. Undirected. Nope, we don't want any of the undirected algorithms. So let's start looking at the directed algorithms. There are individual shortest path algorithms, A star, breadth first search, depth first search, shortest path, shortest path, shortest path, K shortest paths. I still don't want this to be the Wikipedia page. Shortest path, again, visit all nodes that are reachable from a start node. The node will be visited in breadth first order. The iterator stops when there are no new nodes to visit. I mean, really, we could just do this ourselves, I guess. Although this splits a lot. So we'll be able to naively do it for step 1 or part 1. And I think no matter what we do, we need to parse the grid. So I guess we start with that. You can double back. So theoretically, every single path can expand by 4 for every step. So what is that? If we've got 16 steps, then it's 4 times 4 times 4 times 4. So it's 4 to the 16th, which makes it, that's a lot. So I think this is going to be like vaguely a dynamic programming problem, because if we ever have this grid, right, and we are in the same place as another path, then those can effectively be the same. That's not true unless we step it all at once, which is why they did it like this. So that could work. Hopefully that cuts down the number quite a bit, but I don't know. We'll find out. Let's start by parsing. Day 21. See, the other days with nom-locate have been 3, 17, 10. Did we actually use it in 17? Nom-locate. I think we modified this one. Yeah. So maybe 10. This is our pipes one. We've got the direction. Let's grab that, I guess. With XY, parse grid. Let's grab all of this and we'll just pull that in here because we need to parse the grid. Not all of that's going to work and not all of it's going to be relevant, but that's fine. We only have plots that matter and plots that don't. If we store only the plots that we can step on, then we don't really need a type for this. Nom-locate workspace. I always get the name of nom-locate wrong. One of the downsides of the underscore dash issue on crates.io. Okay, so we've got all this. We do need glam because I'm not doing this without an X and a Y. Okay, so we've got a span and a located span. I think we just keep the located spans because that's all that's going to matter for us. We'll pull in the I results. I think we only need a hash set. I don't even think we need a hash map. So then we don't need any of this parsing because this is just extra. Stick a to-do down here. I want north, south, east, west. Those are going to correlate with positions. What does our actual parsing need to be? Anything that's a dot and then the S as well, right? So I'm going to do many one, I guess alt, tag dot, tag hash, pass in the input, handle the error, bring everything we need in the scope. So then we get a located span back and a vec of located spans. Then this needs to be terminated in an opt line ending because this line ending doesn't need to be there, right? It could be there. It doesn't need to be there. So it doesn't really matter. So we get a vec of located spans. So we get that located span string slice, insert the extra. I guess not. Yeah. So why is that located span wrong? Because we're not doing the with XY that I want. Map requires bringing in the parser trait and this all over turns out to be very straightforward today. And then we don't actually even need to do any of this. This is just that. Why is input wrong? Oh, right. Span new input. And this is span good. That's span good. Everything's good. Given everything that we've already done, that's my parsing test. I'm working on another video going over a bunch of different ways to parse stuff, especially for Advent of Code. Test P21, part 1. Cool. Gonna get the watch on the next test going. So this should give us, I don't know, basically everything, right? Oh, we're parsing hashes, aren't we? We shouldn't be parsing hashes. 0, 0, 0, 1. These are not sorted. So let's do a dot length here. 16 is wrong. Oh, right. We'll do opt alt here. Line ending is hash. So we're skipping line endings and hashes. So 11, that gives us 89 of them. That doesn't sound, let's do this in a different, so 80 of them. And the length is 89, so we have S as well. That's exactly right. So we've got all of our positions, plus the starting position. I guess we technically need to know where that starting position is. So maybe I do hash set IVEC to splat 0, maybe. And then this is, all right, if we debug next, this is set and start. Set and start. And this is going to be set and start. And this is set and start. And then we initialize this using hash set new and IVEC splat 0. And then start is not what we want here. We want IVEC 2. And that'll all debug out and we'll show fragment here, which is what we want. So if next.fragment equals S, then start equals next.extra. And is this requiring an ampersand? It is. So tell me where we start. We start at 5, 5. Is that right? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. 5, 5 is where we start. So then I guess, what are we? Standard iter successors, maybe? So successors first and succession. So we give it whatever our seed value is, and then we get whatever the next values are. So we start off with, I guess this really should be a fold. I don't know what we're doing in part 2, so let's just keep it. So we start off with what? Some start, but we really need that to be a hash set because we need to iterate everything. So let's do let starting hash set equals hash set new starting hash set dot insert start. So this is a hash set of IVEC 2s as expected. And then this is just a function that returns the next one, right? It takes the last one, returns the next one. Occupied positions. This is starting hash set. Why is that? Oh, no, that's the wrong thing put there. That's here. There we go. So we'll to do this so it doesn't run forever. And then we got to take the occupied positions, right? We got to do our wonderful IVEC 2 X, IVEC 2 neg X, IVEC 2 Y, IVEC 2 neg Y, dot iter, dot map, right? I guess for each position we need to do this. So let's do let new set equals hash set new. We instantiate a new hash set for each iteration. This is a hash set of IVEC 2s. Then we need to take the occupied positions. I guess we take ownership over that into iter dot, I guess 4, right? For pause in that. Then we do all this stuff. And we need to do 4 of them for each of them. So we map over the, I guess, offset plus position, right? That's a reference to an IVEC 2 though. So we need to do this and dereference it. I guess they're both references, right? So they both need to be dereferenced. Let's into iter this here. There's no reason to not just take that. We don't need it for later. Map to get each of the positions. I guess we filter map because we can do cell equals this, set dot what contains includes, I always forget, contains cell dot then some cell. Probably need a reference on this. So we've got our 4 locations, we iterate over them, we filter out the ones that don't exist in the hash set because anything that doesn't exist in the hash set is either out of the grid or it is a rock, which we can't stand on. So now we have everything that we need to move to, I guess. Set has extend. Does feel a little bit wasteful to just do that though. For each pause, new set dot insert pause. That's it, right? I guess new set needs to be mutable. We don't need anything special here. It would have been cool to be able to use one of the algorithms. Maybe pet graph would be better for that later, but we'll see. So that gives us to do, and then I guess the question is, if occupied positions No, we need to stop at a certain number. So let's just let it keep going forever because we can choose when it stops because we have a successors. Let's skip, I don't know what, 15 was it? And then next, unwrap. And that should give us the set. Let's do last set is a hash set of IVEC2s. Get rid of this to do. I guess this in the end is new set. Skip, unwrap, whatever. Okay, last set dot length dot toString. Okay, so how many steps do we need to go and what number are we looking for here? Starting from your garden plot marked S on your map, how many? Nope, 16. So if we do 6, we should get 16. So this will tell us whether we are skipping the right amount here. That looks right. 6 gives us 16. We're basically just generating every set and, you know, dropping them immediately. I kind of like this approach actually though, specifically because if we want to render this out, we can at every step. And it's not necessarily hard for us to do that. We could just like inspect here, right? And then we have a set, right? Set.length, for example, right? This should debug out all of those numbers. We aren't running no capture right now, so that's not gonna dump out. So I'm just gonna panic it right now, just to show the point here, right? So we've got 1, 2, 4, 6, 9, 13, 16. And we were just able to easily do that. So let's see if that's correct, right? 1, 2, 4, 1, 2, 3, 4, 5, 6. Don't feel like counting that. So 1, 2, 4, 6. These numbers we know are correct. That should be 9. That doesn't look right though. Oh, that's all of them. That's the last one. Okay. I was like, that's not the next one. That's the last one. Okay. So basically we're creating this iterator. And then if we want to, we can inspect. And if we don't want to, we don't have to. And we just skip them and they get generated and go to the next one. So it's wonderful. We could write a print grid function. Everything could be very cool. We could write those to a file there and turn that into a GIF later or a GIF, depending on whether you like peanut butter or not. So the question then is this a function that accepts 16 as an argument? I think it is. So process input 6, right? And then up here we do, I don't know, I32, usize. Let's make it a usize. It doesn't go on that side of the type signature. Step count, usize. And then in our bins and benchmarks, we're going to have to deal with that. I guess for our bin, we want 64. For our bench, we probably want both, just because it's interesting. Bench with input part 1, 6. Well, this could be const. Well, that's criterion, but process, black box. This could be const. Let's do RG const. That's ripgrep for those that don't recognize it. Drop in wherever these consts are. This is what I want. The Devon consts, right? We want this. I'm going to take these and I'm going to go down, yada, yada. This is for part 1. This is a usize. And we black box this input and we use n, right? And this is not going to be 2s and whatever. This is going to be 6 and 64 because that's interesting numbers. And then I messed something up here. This does need to be there. This needs to be not that paren. This can't be a double benchmark, and then we're good. And then for criterion, I'm just going to do like 6 like this and then 64 like that. So for part 1, we run part 1, we do day 21, we run that, we get some number that is hopefully the right number. And if it's not, then it's probably my configuration. That's a gold star. Congratulations, everybody. The elf seems confused until he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and perfect cubes, not his step counter. The actual number is exactly this many steps. He also points out that the garden plots and rocks are set up so that the map repeats infinitely in every direction. Ugh. So if you were to look one additional map width or map height out from the edge, you would find that it keeps repeating. This is just a tiny 3 map by 3 map slice of the inexplicably infinite farm layout. Okay, so we get a number for each of these. I assume doing this is prohibitive. So did we think this will just work if we pass the numbers in? Let's try to take these and throw them into tests and see if they even run. One of these is 5,000, right? So let's grab all of part 1. Let's throw it into part 2. Let's do like the same setup here for the benchmarks, even though yada yada, this needs to be a part 2 and whatever. And then I'm just going to leave this for later. This ending is going to have to be 5,000. And then part 2, we already have all this set up. I think it's just modulo to give us the actual base positions. So I'm not sure we even need to do much here. But let's set up the tests and make sure they fail. And what is our, all of these, copy them in. I guess we'll RS test. We should bring this in to scope. We should write a set of cases here in exactly case some number, get rid of all of these, comma, match these up. Why does it say still reach 16, reach any of, reach 1594? Well, in any case, this is what we're doing. And then garden plots needs to come off the end of each of these. So now we have the steps and the step count as a U size, expected tiles, also a U size. This is step count, and this is expected tiles. I guess we'll two string this. There's an issue because these don't have the case in front of them. That should be fine. So let's run these. These probably fail out pretty quickly. Yeah. One passed because what? Which one is passing? 2 through 7 fail, but the first one passes. So let's do tests, test, process, case. Let's do this one at a time. Make sure each of them pass. 1 passes, 2 doesn't because I think it goes outside. So 2 is going to be our first test case. And I think if we get the grid size and we modulo the position, then we can keep inserting the same way we're doing. I don't know if that will be fast enough, even if we do that, because it's going to be a lot, but let's give it a whirl. So instead of contains, right, we are going to need the size of the grid in both directions. So we've done that before. I think in the other days, right, we need row count and column count. And then back in day 21, I honestly just didn't feel like writing this over again. So it's going to be row count and column count, right? And if we mod these for each direction, we should end up with the resulting number that it should be. So then we do the contains on that and everything should be fine. So can we do mod on an IVEC is a super interesting question. Let's do what, cell, mod, vec, IVEC2, splat, 10. I don't know. I'm just seeing if this throws an issue. It looks like we can. So let's create IVEC2, new, row count, column count. Those are in the wrong order. Okay, well, we're off to a great start. We're going to take this, drop it there, bounds, right? This is going to be bounds, and this is going to be cell mod bounds. And then called option unwrap on a none value. That is happening on 65, which is totally different. It's calling unwrap on input.lines.next. Okay, I feel very suspicious. Okay, that is, yes. Okay, that's the problem because we don't need the new input. We need the old input. So this says 50, right 41. So I guess my other question is this supposed to be -1? No. I guess the real question is, can we get this to work for the first case? Because if it works for the first case, then we're good. It does work for the first case. So does it work for the second case? No, right? In 10 steps, he can reach 50. Whole bunch of them. Is 10 a valid IVEC2 for this though? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess it is. So 0 to 10 are accurate. It is giving us seemingly those numbers. I can't think of any issue with this off the top of my head, except maybe getting too big and wrapping around, but we're running into bugs. So I feel like we would be told about that at the moment. So let's debug cell because that seems like it'll give us the numbers. This barely escapes. So it does get to 13, 4. I have a feeling we might need a bigger IVEC, but not for this one. So maybe we do print grid and we do that in spec that we talked about earlier. How do we print grid this? Day 16, part 1, right? Print grid. We do need to figure out what the boundaries are if we're going to print. Again, anything we don't have is a rock, so that should be fine. So part 2, print grid. We're barely even out of the bounds here, but I think we are actually out of the bounds. So map, boundaries, this, print grid, set, and then what is this? This is the new boundaries. So min max, right? So these two things are what we need. So min max result, set.iter. Min max needs to come in from iter tools. And then I guess this needs to be the other version of it, right? Is this from day 18? I'm doing a lot of grid printing. Let's see, part 2, dig instruction. Here's our bounded grid print, which is the one we want. So let's get that into print grid instead, because we need to do all of that. This says I64 vec2. I don't think we really need that. I'm going to delete it for the moment and make these use ranges. Print grid is not a macro. And then we need this call in here. We basically already wrote the print grid code, so that's cool. Set map of IVEC2s. The issue that that's not a slice. Let's get our test running again. Expected slice. A little weird to do that, but it's fine. I think the issue there is going to be that it has to be a shared reference. So that happens. And then this is a double reference now, I think. Should have a min and a max for X. Really? Did we already print out a bunch of them? No. Set iter map pause X. What is the result of that? One element, 5. Interesting. I guess that makes sense. If set.length, what, less than equal to 1? I guess this isn't really a guarantee either. Yeah, well, this isn't a guarantee either. I think we need to actually handle that. So the debug here is only, right? Which I guess technically is fine. So I guess let's match on this for a second. Get rid of this, fill match arms. We have our min max condition, x min and x max. We have our one element, which is x and x. And we have no elements, which is, I guess, panic. I don't know. It'll panic at the very last one, no matter what in that case. So let x min, x max equal that. Copy this, paste it here, because it's going to do the same thing, right? And then anywhere we have x min, we want y min. Anywhere we have x max, we want y max. And then that should work, right? We need to print some kind of barrier, and we need the print to actually be inverted, I think. So if the map contains this, O, otherwise print not rock necessarily. We don't have the rock list, so whatever. Is step 3 only 3 of them? Let's go back. So we've got 1 and 1, which are inverted. So our y is inverted for sure. This is at 2 steps. 2 steps should be 4, and it's not. What? Hang on. Did we get a different? So this is up and left, which we need to reverse our print grid for, or rather, in this case, not reverse our print grid, right? So we've got this, we've got up and to the right, or to the left, and then that one would go somewhere. I don't know. Yikes. Up, gap left, and then a V. We don't get that V though. It feels like we got lucky on the first one. On part 1, it feels like we got lucky. We're doing our mod right now, right? So let's maybe remove the mod for a moment and see if we get the right answer. And we don't. We get the same answer. Did we get super lucky on part 1? What did I mess up? Yikes. So 1, 2, 3. I thought we had 4. Let's debug set because I need to see this now. We need a print line set because it's not going to be in the right. This is very quickly getting into tracing territory. I feel like I did something wrong. Okay, 5, 5. And then this has 5, 3, 4, 6, 3, 5, and 5, 5. So why do we only print out the 4 of them? Did I miss on my bounds? Am I doing my bounds wrong? Do I really want +1 on these bounds? Well, that's wrong. Minus 1 on the bounds? Minus 1 for min and +1 for max, maybe? Wow, my printing logic is what's the issue here. Okay, yeah, there we go. So we get this, then we get this little V with the pocket, and then we get the V with kind of a slash in it, and then that is correct. So that all looks fine starting out. And then we get, we probably don't have any more to do we? 6 steps we can check 6. So 0, 1, 2, 3, 4, 5, and then this is 6. So it's 1, 4, 3, 2, 2, 3. 1, 4, 3, 2, 2, 3, and then 1 directly under. Yeah, okay, so that looks good. Those all look good. Let's reinsert our mod logic, which is apparently an issue. And that gives us 1, the 2, the V with the slash, and the 1, 4, 3, 2, 2. Yeah, okay, so that all looks good up to 6. We do get numbers with 12 in them here, so I'm inclined to think that that's fine. Am I repeating it wrong? I feel like I need to map the rocks. I was trying to avoid mapping the rocks, but I do feel like I need to map the rocks. So because I'm probably going to I feel like I'm going to take the rocks out later. So I'm going to do not parse grid, but parse rocks, parse rock grid. And then this is just going to be hash, and we'll get the same information we just got out of it, right? And this is a dot or S. And parse rock grid should be able to give us that hash set, and then we ignore the input rock set. And the start is just not relevant here. Span new input, rock set, and that's when we take it down here. We do the same thing, I guess. Well, this can just be the hash set. And then for our match here, I guess we just mapped on both, right? So rocks dot contains, I guess not just the ivec2 xy, but the mod of that on the bounds, right? So we need to keep those bounds around and do it again. So this is going to be that. This is going to be that. This is going to be true, false. Or actually, this is going to be true. We don't care. This is going to be false, false. And this is going to be true or false, true. And this will be print hash. So that should place us some rocks, even if it's only like the interior rocks. We do need to pass that in. Parsing error because what did I do wrong? Ooh, do I not have the right list of stuff? No. I guess this is supposed to be terminated in anything, right? I don't think I messed up the parsing. I think I just wrote the second parser wrong. So if we're trying to parse just rocks, right, then we can take until hash like this. I guess preceded is really what I want. Okay, and then we get our printout, right? And this should start giving us the rocks. So let's pull this over, replace it there, and then make sure we're in the right one, 0. So 0, 0 should have 2 rocks above. 0, 0 should have 2 rocks above, 2 to the right, and 1 below. That makes sense. So if the rocks are all in the right position then, right, and we start scrolling down, then our issue here is that we haven't expanded the rocks. And the rocks expand from, I guess, the top left. So for this row, if we can find this pattern, dot hash hash hash, right? Hash hash dot dot hash. So this should then have one more dot and then a rock here, and we don't. So let's try to find out if we can do that with the mod, right? Because we're contains on this, but when we do our percent, which is cell percent bounds, so we need to pass in bounds, which we will have access to at this point. So let's just do rock bounds, I guess. And rock bounds is going to be ivec2 because that's what it is, unless it's a reference or something. It's just going to be bounds. Here it'll be rock bounds, and then it's this mod that, do that like this. What is our reference issue here? Couldn't find bounds. That's because it's rock bounds. So theoretically, this should start spitting out the rocks everywhere they should be. So if we go back down to one of these where we can find something like this, right? So like this one, this does 3.2.1, and that is 3.2.1. I think that's where we are, which means that it should be dot dot and then 3 more, which it looks like it is. My biggest question then is if we are repeating the grid correctly. It looks like we have 2 spaces here and 2 spaces here. We do have 2 spaces in both of them, or I think all of them. So that's probably good, which means that our rocks are being positioned in the right spot. So why is our logic wrong? 41. Are we counting something else? He can still reach 16 garden plots. I feel like there's going to be a cycle thing that we have to do here, but I'm really interested in getting this logic correct first. And why are these written differently? Why is it in exactly 6 steps he can still reach 16? In 10, he can reach any of, wait, are we doing the right number? 10 steps, right? So this should be the 10th grid, or I guess the 11th grid, right? Because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we need the next one, maybe. I wish it gave us the 10th grid. This is just the grid. So if we did something silly and forced that to print, right? And our min max here was, if instead of rock bounds, or rather y min x min, did something like this, and they're range inclusive, and that runs and gives us something. So that's weird, right? 4 bounds, 4 bounds. if the map contains and the rocks contain, then we print certain things. I guess this is our 3x3, right? That's what we were looking for, but it's the wrong 3x3. It doesn't work negative. No, that's our issue. Oh, that's the actual issue. It doesn't work to the negatives because we are not doing specifically rem Euclid. That's potentially the issue. That is an issue for sure. It may not be the issue. But let's get our mod working. Rem Euclid bounds. At the very least, that passes. Okay, let's comment out this inspect. That's all it is. It's just rem Euclid. So, I mean, I guess we should look at rem Euclid on IVEC2 or whatever, but it doesn't really matter. Calculates the least non-negative remainder of self, mod right-hand side. This is done as if the Euclidean division algorithm given R, yada, yada, yada. Basic usage, 3, 1, 3, 1. So then we're just doing our math inside of our grid, which is fine. And we have returns the element-wise Euclidean division of self and right-hand side, or the remainder, which is exactly what we just looked at. I always forget that one. How many of these test cases do you think we can pass just running like this? We got 3 of them. Do we just say that's good and go for it? Well, first I need to be able to kill the task process. No. Oh well. So if we just send it, there's no way this finishes, right? I mean, I guess it's just an absolute boatload of mod operations and stuff, but there's no way, right? How many steps do we need to get and how fast are these going are 2 questions in my head right now. I guess let's do .inspect and not use it, and we'll .enumerate. We'll take I and we'll do that, and we will print line I. Skip next, unwrap .1, because now it's with the extra stuff. Oh, that seems so slow. That's really unfortunate. How many steps is it for actual? This doesn't even pass the tests, right? And it slows down greatly even as we get higher. So it's not getting any faster. I assume that's because we have just an absolute mass amount of stuff. Although it's not showing up on my memory list. Pretty incredible that that's only taking 57 megabytes. I assume that's going to grow as the thing traverses, but that's quite a bit. So the memory usage, super stable, 57 meg, single CPU, using all of it. I don't think parallelizing this is going to do good enough because what is the number? We're at 1500, all right? 1500, and we need 26, 50, 13, 65. So we need an extra 4 digits on this. So that's not going to work. If that's not going to work, then we're left with what? I guess we shouldn't really depend on the test input because that's led us astray quite a bit. So anything, even just seeing whether the outer row is truly empty, is going to take verification from the input. This is some grid, which will repeat, have 2 empty spaces between it and the next one, and then keep going. Unless the grid that we're currently in repeats, I don't know how this would be solvable. So I think that this is, again, a cycles issue. So reaching out to find some kind of repeat in very specifically the set we start with. Do sets have equality? I don't think so. Oh, it looks like they do. That's probably really useful. So those are not equal. Let's make sure that the same one is equal. So I think we just need to store the set for only the positions we care about and find the cycle. And then we use that cycle again to do that a bunch of times and skip all the computation. And then that should result in some number of repeating grids. That doesn't sound right though, because the repeat would also have to fill in like the test grid, right? So if we had this and that was in a 3x3 grid, right? Or something like that. And it starts here in 5x5, which is what? Exactly half? 1, 2, 3, 4, 5, 6. This is 0, 1, or 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. It is exactly the center that has to be meaningful. So if this is at the center of the grid, then this grid plus something else though. Is it the 3x3 around it? Is that whole area need to cycle? Because it needs to spread out and fill. And this, if we zoom out here, very interesting. This forms a diamond shape of empty slots. I wonder if that's important. I haven't verified that at all, but it's surprising me to see what looks like a very clear diamond shape here. I wonder if that's the key. I wonder if it's not actually a cycle in the rectangle. I wonder if it's a cycle in the diamond inside of the rectangle. Or if that, because there's this gap here, that it is repeating in the exact way that we need it to. I think I'm going to think about this, put it down, come back, because it's got to be significant in some way that this input is specifically aligned in some way. Okay, so I spent a bunch of time thinking about this, a bunch of time working with it. It's hours later right now. What I figured out is that if we, in our inspect where we were printing the grid, if we print out what is effectively the grid width for our input, and it starts at 65, and we have those sequence numbers. So this is the amount of squares that are filled at each of those locations. This forms a quadratic sequence. The number that I feel like I'm supposed to calculate is 202300, because that's cleanly divisible by 131, which is the x and y, or the width and the height of the input that we're given, if you just look at the number of characters. And this sequence, of course, if you take those numbers and you subtract them from each other, you get like the first differentials or the first subtractions, right? And if you subtract those from each other, you get the second. And the second order, I guess, the second differentials, not the differentials, the second, like, you subtract the first two and then you subtract the second two. And this is all the same number for every two numbers, every two of these numbers. So this overall means that we have a quadratic equation that is generating these sequences. So the fact that we have the quadratic equation generating these sequences, and the fact that this number is 26,501,365, which is like just a random weird number, except that it's not, it's special. It has to be there because that's where the sequence is. So this is something like step count. This is not actually a step count, if I remember correctly. I'm losing it a little bit right now because I don't have the answer yet. I've been working on this for a long time. But this is the step count, and this is like 2023, the year, for whatever reason. The line length and what I loosely called the step interval, but it's more like an offset 65. So if you put all that together, and I haven't done quadratic stuff in ages, so it took me a while, but if you put all of that together, then you get a sequence that is like this. If you look at Wolfram Alpha on the right hand side of my screen, this is the sequence numbers, so 0, 1, 2, 3, 4, 5, whatever, and the values that come out. So that is these values here. And that is this equation. So 14,871 times x squared plus 14,735 times x plus 3,642. Now, just because I have the sequence equation doesn't mean that I am actually able to solve the problem, because I'm not getting the right number out of this input. So this one's too low, this one's too high, and I've been blocked out from effectively submitting responses. So every time I submit a response, I have to wait longer now. So I'm not sure. I think this is it. I feel like I'm very close, but I also can't get it to produce the right answer. So I don't know. I'm gonna try to figure something out. I'll probably try to read some answers tomorrow after I get some sleep and figure it out. In any case, this was a day in which you really got to look at the input, really got to, like, guess some things about some stuff. If you zoom out, I don't know if you can see this in the YouTube video, but there's this like diamond shape here, empty lines on the outside, empty lines as a cross in the middle as well. But I just couldn't put it together today. I feel like I'm really close, but I didn't get it. So I'm going to move on with that. This is my, yes, I have to wait 5 minutes before trying again because I've guessed incorrectly 4 times. So I don't know. It's not even telling me whether I'm high or low anymore. So now I'm really just guessing. Hopefully I'll be able to get up tomorrow and work through it again. Oh, I need to take these. That's what I need to do. I need to put those numbers in. I wonder if those aren't even on the sequence, are they? Anyway, I'm gonna call it there, and hopefully I can figure it out tomorrow. Have a great rest of your day, and I will see you again for day 22.